the basic projects we have been did. Okay, so like the level 1 projects. Okay, so the level 1 projects of it's be like interfacing with the sensors and peripherals, and we saw the timers, GPIOs, interrupt, UART, so ADCs and all we have been done in this past day. Now we are going to be combine the stuff. Okay, so what we are going to be combining? So past projects, so which we are done, like how to interface. So we had used one ADC module, that is we are used one pot meter. Okay, so with the help of this pot meter, we just read the voltage value. Okay, so we are read the voltage of STM32. So which is one has been connected and ground, another one is connected with this 5 volt. Okay, so based on this analog data, so which is going to be connected on this another analog pin. So based on this, it is going to be change the value. Okay, so here it is considered as an analog voltage. That analog voltage is going to be converted to the digital form with the help of this ADC converter. That's what the project is. So today what we are going to be do the project is, it is going to be the temperature logger system. Okay, so here what are the things which have been taken as ADC, UART and timer. Okay, so what the project which are going to be do first, so I'm going to be tell you that, and later we will do this project. Thank you all the people, Kushali and Kishore Kumar, so really excited about your messages. Okay, so the thing is, so first I need to be tell you that what is the overview of the project, and then we are going to be execute the project. Okay, in this first of all, the project implements the real-time temperature monitoring system on the STM32F411 microcontroller using bare metal register level program. So first of all, it is going to be the temperature monitoring system. Okay, so the data you're going to be collecting. Okay, the data. The system reads the analog temperature values from its LM35 sensor through ADC. So first of all, you are going to be taking one temperature sensor. Okay, so you are going to be take one temperature sensor, that is LM35. Okay, so we have to take a temperature sensor. This is LM35 is one of the sensor. Okay, it is a temperature sensor. So through this temperature sensor, we are going to be read the temperature values. Okay, well, so it is having it is going to be providing the temperature value. Okay, we cannot directly take the temperature data, which is going to be like degree Celsius. So for that, what we are going to be do is, we have to be collected the analog format of data. Okay, analog format of data. Why we have to consider it as an analog format of data? Because it is a temperature data, temperature sensor. The data will be continuous and time. Okay, so you just consider this is your this is time. Okay, if you are just considering with the timeline, this is your data. Okay, this is analog data, the temperature data. So the temperature data is continuous with that, because at every instant of time you will getting a data. Okay, so that is going to be considered as an analog. So we cannot directly taking a temperature data. We have to be collect the analog data. Okay, so this analog data we have to be converted into the digital. Okay, so we have to be converted into the digital. For that, we have to be use the ADC module. That ADC module which is present inside the STM32 microcontroller. Okay, we have to be configure this one first. So I hope my voice is clear, guys. Please give me the acknowledgement on the chat box. Is my voice is clear? Is everything is going good? Just give me the acknowledgement. If it is not, so I think problem on your side, Gilbert. So I'm going to be verify with my team. Okay. So please give me the acknowledgement, guys. Yes, clear. So thank you all the people, Varnit Gupta, Jay Krishnan and Aravind, everyone. Thank you. So check your side, Gilbert. Okay. So yes. The thing is, guys, we have to be collect the analog data. Okay, that is going to be converted to the digital with the help of the ADC module, which is present inside the microcontroller. So this is the first phase we have to be to, like phase one. Okay, not exactly phase one. This is the first step. Okay, we have to be do collecting the analog data. We have to be read the temperature value. Okay, exactly. Yes, exactly. So I'm going to be post a message to the to he actually he can hear my voice, but my voice is unclear actually. So the problem might be the network issue. He can hear my voice, but not properly. So the thing is, guys, we are going to be choosing the LM35 temperature sensor. So there is a LM35 temperature sensor. We are going to be interface with the microcontroller of STM32 microcontroller, and we have to be collect the data, which is in the form of analog. Okay, which is in the form of analog. And after we have been collected the data, we have to be transmit reading through the serial wire. That is a UART. Okay. So after that, this is the first level. And the second thing, you have to be transmit the data. Okay. So the data which you have been collecting, analog to digital conversion, you are going to be doing. The digital format of data, you have to be sent to the any other device or any other microcontroller, any other things you are going to be transmitting. So for this device, we have been taken the Arduino to be transmit the data. So for to be transmit the data, we have to be use any protocol. In this when we have been chosen the UART communication protocol. Okay. So through this UART, you can transmit the data easy. Okay. And here, this is the second thing. So I'm going to be collect the data and transmit the data of this digital data is going to be transmitted. So while you're going to be transmitting one data, so it needs some delay. Okay. So first of all, for if you are just sending one data, which is 1400, it is in the digital format. And this digital format, which is no guys, it is external sensor only we are going to be use. Okay. External LM35 sensor we are going to be use. Here, the digital format is going to be converted into the exact degree Celsius value. We have to do some math to be convert this value to this degree Celsius in this code and all. Okay. And this is fine. But if you're sending one data, the another data is 2500. Okay. Because the resolution value is from 0 to which is 4095. Okay. So you can able to send the digital data within the stage. Okay. Based on that, you can able to uptime the data. So you can able to send the data. If you're sending this data, what is the timeline? So the duration of the next data going to be sent. So it might be within 1 second or millisecond. So I'm going to be sent within 1 second. Okay. So this is the actual project we are going to be doing. So this is third. So here for to be generating delay, we have been create the timer. Okay. We are going to use the timer. Yes, exactly. Arduino. We are going to be send the Arduino board. Okay. So hi Thirmal. So this is the actual project. The first phase is you have to be study about the analog to digital converter. So we have to connect the collecting the analog data. Okay. That analog data is going to be converted to the digital form with the help of the STM32 microcontroller, which is having inbuilt ADC. Yeah. And then we have to be send the data to your Arduino. Okay, so we are going to be send the data to the Arduino with the help of the UART communication protocol. And after sending the data, meanwhile, while you're going to be sending the data, what is the time duration? So after the next data is going to be sent. Okay, we have to be considered. This is the whole project which you're going to be do. So it is definitely going to be help you to be understand, and you can also implement it by yourself. Okay, you can also practice. So before going to be do this project, first of all, I'm going to be simply tell you that what is LM35. LM35 is the temperature sensor. Okay, it's a temperature sensor that gives you the analog voltage that changes with the temperature. So actually, it is going to be temperature sensor means it is going to be analyze the temperature values. Okay, so changes with temperature, it is going to you can able to read by the analog voltage. So previously, we used quad meter. Quad meter is just voltage, analog voltage reader, right? So we can able to adjust the voltage value. For example, if I connect ground and power supply, so based on watt meter is type of resistor, adjustable resistor. Okay, so the pot meter, you have been connected the pot meter in the center. You have to be connected with Arduino. Okay, so it's not mandatory. Instead of using Arduino, you can use ESP32 or PIC microcontroller, 8051, anything you can use it, because that is going to receive the data, and just you are going to be visualize the data through this any microcontroller. Okay, it's not intentional, so I'm choosing this microcontroller. So the thing is, based on this, you can able to adjust the value. Okay, if you are just adjusting the, you are just moving the trim pot towards the 0 volt, the resistance value will be high. Okay, so towards this 5 volt, so based on that, it is going to be works. Okay, so it is going to be do, and the temperature sensor, it is having this values. One is 4 to 20 volt. It can able to get the input voltage. Okay, that means the VCC. Okay, so you are going the exact temperature sensor which you are going to be using in our project. So the first is that is a supply voltage. The supply voltage which you are going to be give this, I'm going to be give 5 volt, and here this one, so it is a middle pin which is going to be connected with this analog pin, okay, of STM32 microcontroller, because we have to be read the data in this analog format. Third one is the ground, so that's what I've been given here. So the thing you are going to be learn on here, it is just a temperature sensor. We are going to be read the analog voltage. Okay, this is what the thing it is. So after that, we have to be work on the complete code. Okay, so it is literally easy. You can easily to be understand the concepts, everything. Okay, so first of all, before going to be start the session, so I'm just open up the data sheets and reference manual. Just definitely mandatory to be understand about your microcontrollers. Understand, you have to be write a code from the scratch itself. Okay, so I just open up the both the sheets. First of all, first, if you just any microcontroller, if you are going to be study about this, guys, you need to know the internal structure of the microcontroller, right? So if you are just taking Arduino, if you want to be know about the Arduino, you have to be understand what the processor inside the microcontroller, and what is the memory size, and whether what is the bit of ADC, what is the resolutions and all, you need to be studying, right? So here also we are to taking a STM32 microcontroller. So I need to be study about the internal block diagram. So what is the processor has been used, and what is the memory size, and what are the peripherals that's going to be supported, and what is the connections and all, I need to be study. Yes, that's fine. So same thing I'm going to be implemented for to be understand this microcontroller things. I need to be open up the data sheet. Okay, here I can able to see the features and all. If you just see this one, where is the block diagram? So here you can able to see this functional overview. Okay, you can able to see the first of all, you have to be open up the block diagram, which is very important thing. Okay, which is in this here, page number 15. Okay, so in this one, this is the complete internal structure of your microcontroller. Okay, so you might be having what are the peripherals inside your microcontroller chip. You can able to see it visual. Okay, so it's going to be understand very clear. So these are the peripheral which is inside the microcontroller. In this one, what are the things I'm going to be used? What are the peripheral I'm going to be used? I'm going to be used a timer. Okay, here I'm going to be using a timer. I'm going to be using a UART. Okay, so I'm going to be using. Sorry, guys, it's some glitches happening. So I'm just to move this one. Okay, so here you can able to see this one. So I'm going to be using a timer. Okay, here I'm going to be using a timer. I'm going to be using a UART. Okay, so we have to be use the UART. So UART 1 or the UART 6 we are going to be used, and then ADC we are going to use. Okay, so three peripherals I'm going to be using here. Okay, so yes, so this is the peripherals I'm going to be using. Okay, guys, I'm definitely going to be send this PDF file, okay, to you, okay, at the end of this live. So this thing is, we need to be configured. So I've got the idea, okay. So what are the things I need to be configured? So I have to do the timer, I need to enable and ADC and use that, okay. We will confirm whether you are going to be use 1 or 6, okay. It's based on the application. We can use any of the user. At the same time, we can use any of the timer 10, 9, any of the things based on your application. Okay, so here I'm not using a user two, okay, because your USB is also being connected with this user two, so I'm not using this user two. Instead, I just use this either I can use user one or user six. Okay, so the thing is, we will do this procedure step by step. Okay, first of all, if you just see this one, the system clock and peripheral enabling. Okay, so here I'm going to be use the three peripherals. The very first thing what you are going to be do is here you have to be verified all the peripheral. You have to be enable the clocks. Okay, you have to be enable the clock for the all the peripheral. Okay, here I'm going to be use the okay. First, for example, here I'm just you can able to see that I just use the ADC, use that one, and finally I just use the timer level. Okay, three peripherals have been used. I just so timer level, use that one, and ADC one. Okay, so three peripherals have been used. So definitely we know that if your microcontroller has been in this structure, okay, for example, this is your other peripherals. Okay, so this is your processor and this is your uh like memory and this is your GPIO, like this is ADC, this is timer, and this is UART I2C. So these are the peripherals which you are having. Okay. So we know that if I want to be configure this ADC, if I want to interface with any LM35 kind of temperature sensor, I want to be interface that, how can it is possible with the help of the GPIO pin? Know that. So GPIO is a general purpose input and output. With the help of this GPIO, you can able to send and receiving the data. So the main important thing is you need a GPIO pin. Okay, you have to configure the GPIO. Okay, so for example, if you want to be configure the timer, you need the GPIO. Okay, so through this GPIO, you can able to configure that. If you want to configure use that, you need a GPIO. So for all has been connected with any of the GPIO pins. First of all, you have to be enabled. So for what I'm going to be doing is I'm going to be check that I'm going to be using timer 11, UART 1 and ADC 1. So for all that, I need to be find it out which GPIO open it has been done. Okay, so how can I able to find it out whether which GPIO open it has been connected? So I'm just simply open up the pinouts. Okay, so in this pinout, I'm just opening the pin definition. Here you can able to find which GPIO it has been connected. Your peripherals has been. Okay, for example, if you're just taking the first of all UART 1, right? So here it is UART 2. You have to be find it out the UART 1. For all the peripherals, you have to be find it out the pin number. It is UART 6. Here I'm having a UART 1. So it is connected with this port A of. So for UART 1, I have found it out port A of 1. Okay. So likewise, you have to be find it for the other peripherals like ADC and all. Okay, you can easily find it out it has been where it has been connected. So by watching through this pin definitions, timer 11, Okay, here the ADC has been there, guys. Okay, so you can also find it out the value ADC1. It is connected with this port A of 1. Okay, so I've been find it out ADC1 is connected with port A of 1. So both has been port A of 1. So not exactly, it's port A of 9. Sorry, I've been written wrong. It is port A of 9. It is port A of, okay. And finally, how to be find it for the timer 11. Yes, here the timer 11 is there. It is connected with this port B of 9. Okay. So then the timer 11 has been connected with port B of 9. Okay. So here I got the GPIO pins. All the GP. Thank you, Prashant. Thank you for the acknowledgement. Thank you. Thank you. It's port A of 9, guys. I was written wrong. It is port A of 4. Okay. So I got the port A of GPIO pins. I'll find it out for the specific peripherals. Once you have been find it out, here all has been based on the clock. So you can easily recognizing that. So this timer 11 has been connected with the GPIO uh, B of 11th pin. Specifically, it has been connected. So likewise, the UART1 has been connected with this GPIO of 9th pin. And ADC1, it has been connected with this pin of what? It has been connected with the pin of first pin. So likewise, you can easily connecting. So if you just open up the your microcontrollers, okay. If you just see your microcontroller, STM32 microcontroller, you can easily interface that. Okay, you can easily interfacing with the GPIO, right? So with the help of the GPIO pins, you can connect it with any external peripherals. You can do it. So how you can actually doing? So internally, it has been connected in this manner. So this is what you're going to do. Okay. So I have easily find it out the things. Okay. So after this, okay, you have to be after you have been find it out this, you have to be enable the clock for the GPU. So inside the all the peripheral has been connected to this bus. So this is the parameter of while you're going to be study about the microcontroller. So the microcontroller internally it has been connected with this bus. So bus means it helps to transmitting your data and receives the data through this normally we call it wire. Inside this microcontroller we have to call it as bus. Okay, so it helps to transmitting and receiving the data. So for that, first of all, you have to be through this HV1 bus, you have to be enable the GPIO A and B. Why? Because we have to be use this two GPIO pins. Okay, so how you actually going to do this procedure is first of all, you have to be write the enable the clock for this one. Okay, first of all, you just simply check it is connected to this HB1 bus. Okay, so you just simply go to the reference manual and go to this RCC register. And inside this RCC register, you can able to see that AHB1ENR. Okay, in this AHB1ENR, it has been connected. What are the peripherals being connected to this AHB1 bus? You can able to see it in this map. Okay, so in this AHB bus, it has been you have to be enabled the GPIO A and GPIO B. Both the thing you have to be enabled. So how you can able to enable the bits and all? So you have to be do the bit manipulations. Okay, so I need to be enabled these two bit. First of all, it has been connected in this bus. Okay, so for to be identify this, I just open up this SFRs. Here, I'm just go to search for RCC register. Yes, inside this RCC register, you can able to see this AHB1 ENR. So in this AHB1 ENR, you have to enable the address. Okay, so in this method, we just declare this point in this form of pointer. Okay, so simply you have to be do the what the type of pointer you're going to be use. Okay, based on that, it is going to be set the memory size. Okay, it is an integer pointer. If you're using a character pointer, it is going to be allocated 1 byte. Since it is having a integer pointer, it is going to be allocated the 4 bytes because it is a 32-bit process. Okay, here I'm going to be use the peripheral, the register name itself, I'm just use it as a pointer name. Okay, so it is a AHB, whatever the name you can give it, guys. Here I'm just using the same name of AHB1 ENFS. I'm just using the dereferencing, which indicates I'm using a pointer. Okay, which is going to be telling you that I'm using a pointer. Okay, so here this pointer, I'm just directly using the address. Why we have been studied about the pointer concept. In this previous pointer concept, how we have been studied, we have to declared one data. So that we have to use data. We have to declare one variable. Okay, so 10 has been stored inside this variable. If you want to be know the where this a variable has been stored, for that we have to be declare the pointer to be hold it. Okay, so this is how we have to be declare the pointer. So it is going to be hold the someone address, someone variable's address, right? So we have to be declare that like that. So it is actually storing the address. Ampersand of A means it is the address of the A variable. So here we are directly doing it. We are directly storing address. Okay, so and here we just doing a typecasting. So here we just doing like a typecasting, like it is an integer type. Okay, for that it is an integer pointer. So for that we just typecasting has been made here. This is the same procedure we have to implementing all. Okay, just copy, 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 copy. And what are the peripheral you are going to be using that? We just change the peripheral name and address name. It is very, very important. Okay. First of all, what I did is I just enabled the GPIO-A and GPIO-B. Both has been connected in this AHB1 bus. That's what I just commonly declared that. And now, after you have been enabled this one, it has been completed. And I've just come to this point. Okay. And scroll down. Here, I'm going to be enable my GPIO pins. Okay. I'm going to be enable the GPIO pins. Here, before you are going to be enable the GPIO pin, guys, you have to be initialize what are the things you are going to be configure. Here I told you the three things I'm going to be use. Yeah, so this address we can take it even from this here, guys. You can also easily take it from this ID. Okay, so don't confuse it. All the peripherals. Okay, in this page, if you just go to the data sheet. Okay, so all the memory values and all, okay, in this data sheet, you can able to see the peripherals. If you're just taking AHB1, so in this AHB1, you are having a GPI opens. So you can easily find it out all the address and all easily. Okay, you can easily find it out the address values, everything you can able to take it from there. Okay, so it is telling a boundary address. Okay, it is actually telling the boundary address, but here you can able to get it all the peripheral exact address it is going to be provided. Okay, so you can able to see that it is actually going to be provided the what is AHB1 ENR. So what is the address of this AHB1? Okay, so here you can able to see that it is AHB1 ENR. So every address you can able to get it from the ID itself. Okay. So, Kaplesh, Alpesh, what's the exact problem you are facing? You just tell me on the chat. So you just tell me your issue. I'm going to be share it to my team, so they will support. Okay. So the thing is, guys, here I'm going to be use the HB1 ENR. Here I'm going to be enable the GPIO. GPIO A I need to be enabled for to use it in my project. Okay. So if you just see this one, if you just see this one, this UART one is also required GPIO A. ADC one is also required GPIO A. Okay. So, but it is a pin number 9, it is pin number 1. So that is the difference. If you are taking a UART one, it is using a GPIO A, ADC one GPIO A, but the pin is different. But timer is port B of 9th. Okay. So what I'm going to be doing is, first of all, I'm just using one function. Okay, so I already declared the functions and all. Okay, I already declared the functions. So after this, I'm just simply calling this functions. Okay, so first of all, what I'm going to do is I'm just declaring the function. It is not going to be written any parameter, any values. It is not going to be written. That's what I'm just using a void. Okay, why I'm going to be using this function is it is only going to be using for initialization. Initialization in a sense, what are the pins you required it and what the pin is actually going to be performing and what are the bits you're going to be enabled, all the things you're going to be do it on here. So that's what I'm just doing the initialization. So ADC going to be initialized, user going to be initialized and timer going to be initialized. You can able to see that. Okay, all has been initialized. Three function have been declared for to initialize that. Okay, so first of all, you're just taking ADC, GPIO, A I'm going to be used. But first of all, you don't consider about the pin width, which pin it is. You have to see which GPIO pin, GPIO port it is. It is a GPIO A. Okay, for that, what I'm going to be using is I'm going to be using a register. Okay, this is the register name, pointer register name, and I'm going to be using that pointer register name here. Okay, and here you just go to the reference manual. So I'm going to be enable the GPIO A for ADC and user. Okay, so I'm going to be enable this one. For that, I'm just simply putting one. One I'm going to be set. So at the position of 0. Yes, I'm going to, we will discuss this, Kalpesh, okay, at the end of the slide session. Okay, so don't worry, I'm going to replay this. So here, if you just see this one, why we are going to be using 0 here, 1 here, and why we have to use the left shift operator here. So in most of the cases, while you're going to be setting the bit, you have to use this OR operator and left shift operator. So the logic we have to use. So here I'm going to be set the bit 1. Why you have to be set the bit 1? Because of GPIO A, you have to be enabled. You have to be enable the clock of GPIO A. You have to use 1 at the position of 0th bit. For that, I just put 1. Okay. So what I'm going to be do, I need to be check what are you going to be set. This is going to be in this left hand side. And how many time you are going to be shift? It is going to be in the right hand side. And this is the left shift operator. Okay, so when you're using this OR operator, which is helps to be set at the bit. So in this case, how it is actually going to be working is, I'm going to be tell it for one thing and you can able to easily understand for the other peripherals. Okay, so in this case, I just use the pointer of AHB1 ENR or of is one of left shift. I'm just doing the left shift. I'm going to set the 1 at the position of GPIO. How it is actually working? How it is actually working is it is considering the GPIO A AHB1 ENR, all the register bits it is going to be taking. Like it is going to be taking all the bits. All the bits. Okay. If you're just checking out, if I'm going to be enable this one, so all has been the reset condition. All has been in the 0th or reset condition. All the bits. Okay. In that, all the bits you have been taking in this left hand side. Okay. How it is actually taking 0, 0, 0. So all the peripherals is gonna be taken. You have to be do the OR operation of the GPIO A. In that GPIO A, you have been specifically enabled. That time you have only enabled this bit. This bit. Other bits are since it is in 0th position. Okay, 0, 0, 0, 0. All bit are 0. Only GPIO A is only enabled. When I do this OR operation, what will be your answer? What is the operation of OR, guys? It is doing any one bit is higher. Output is higher. The output will I get is 0, 0, 0, 0, 0, 1. So finally, I'm going to enable this GPIO A. So it is going to be assigned on your GPIO A, AHB1 A. So finally, you can do this procedure. Just simply enable the GPIO A pin. So for same thing you have to do for your GPIO-A for the UART 1 in initialization. Okay, and timer, what you're going to be doing in timer 1. So you people are going to be tell the answer without saying my PPT. Okay, what you are going to be do, guys? What the answer you will get? So I'm going to be waiting for your message. What you will get it? No, guys, the address is not going to be changed. Why? Because your GPIO-A or GPIO-B both are presented in this AHV1 bus. So, which is holding common address. Inside that, you are having the different bits. Okay, you have to do the bit match. Okay, the question which I asked you this timer. Okay, here I just configured for this ADC1 and UART1. The timer which is presented at the GPIO. Okay, so I'm going to be asking you the tough question. It is very, very easy. So for that, I'm just simply doing this, guys. So in this RCC, it is you have to be find it. You have to be enable the GPIO-B also. It is also connected in the same bus. I'm just using this peripheral. Okay, here the two methods is there. So here I'm just using simple pointer, but here I'm using like volatile. Okay, volatile means it is actually going to be continuously going to be changed. So whatever the register which is present in that inside this peripheral, it is actually going to be varies. So here hash define of the peripheral value have been declared. I'm going to be return the address. Okay, so here I just using the I'm going to be enable the timer 11 which is connected to this GPIO-B. For that I have been used one. I'm going to be set on the position of GPIO-B. It is located at this first position, so I'm going to be shift up to one time. I can easily get this position. Okay, so that's it. So finally, I'm going to be enable the clocks. All the clocks has to be enabled. Okay, for GPIO. After you have been enabled the clocks for all the GPIO pins, you have to be the GPIO has been enabled. You have to enable the specific peripherals of the timer, UART, ADC, and all. So you have to be enabled that. So for you have to do this, you have to be check which bus it has been connected. Okay, so these three peripherals has been connected with this ABP2 bus. So through this ABP2 bus, you can able to enable all those stuff. So same thing you're going to be do. What you're going to be doing now, you have to go to this ABP2. ABP2 ENR. You can able to see this ABP2 ENR. Initially, you have to be write the address. So same thing, you just copy this. And the only thing is you're going to be change the register. That is a pointer name. The based on your register, just give the same name. It is not going to be confusing. And give your address. You're just taking the address from here, guys. You're just clicking this register name. So it is going to be open up. Okay, you can easily copy this and paste it on here. Okay, so this is the register address. Okay, after you have been enabled the register address, what you are going to be do? You have to be enable the peripherals for you have to be enable the ADC1, UART1, timer1. Go to the reference manual and ABP2 bus. So here I'm just having a RCC. In this RCC, you can able to see this ABP2 ABP2NR. So in this ABP2NR, you have to be enable the ADC1 and timer 11 and UART1. So three things have to be enabled. Okay. So what I'm going to be do first of all, I'm going to be set with the help of the shift bits and or operator. I can easily do this procedure. Okay. So yes, the recorded sessions we will discuss at the end of this live, guys. Okay, I'm going to be tell you at 6:45. Okay. So the thing is, you have to be enabled those peripherals for what you are going to be do. You have to be enable the peripherals. Okay. First of all, I'm going to be enabled for the UART. What I'm going to be do, I'm going to be set one on here. For that, I'm going to be shift the bit up to 1. I'm going to be shift the bit up to 1, 2, 3, 4, 5. Yes, so based on that, guys, so in sometimes uh, read the question properly when you're going to be attending any interviews and all, or like when you're doing write a code for any microcontrollers in your works and everything. So based on that, you just check it all those things. So the starting positions and all. Okay, so 1, 2, 3, 4. If it is started from here, you have to be shift the bit up to 4 times only. But since it is started from 0th position, you have to be use 5. And how many times you are going to be shift this value? Sorry, 1, 2, 3, 4, 5. Yes, it is a 5 position. And other than that, you have to be shift the bits based on the all the how many times you have to be shift. Okay. So for ADC one, we have been shift up to 8 times, and use that one we have been shifted up to 4 times. We will check it properly. Okay. Okay. So you have been checked with 1, 2, 3, 4. Exactly, it is 4, guys. It is my mistake. Okay. So sorry for this. And I've been confused here. Okay. So you have been shifted it up to 4 times. So it is you don't need to be confused about this. You just easily check with the position. Okay, I told you the trick, right? So what you are going to be what you are going to be set. Okay, so in most of the shift operators, in this left hand side, it is actually going to be tell you that and what you are going to be shift or the value they have been mentioned. For example, 15 and all. So in this right side, they have been mentioned how many times you are going to be shift. For 15 means if it is a 3 presented there, in 15 what is the value of 15? It is 1111. Okay, you have to be shift up to 3 times towards the left side. So if you are going to be shift the bits toward left side, you're going to be add 1 bit, add 2 bits, 1, 2, 3. So this is how you are going to be do this left shift. Okay, so same thing we are going to be implemented on here. Okay, so I'm going to be shift on now 1. I'm going to be and how many times I'm going to be shift? 4 times I'm going to be shift. Okay, so it is going to be works. So UART one is also enabled. At the same time, you have to be enabled for this ADC one. So for ADC one, you are going to be shift up to 8 times. And timer 11 also you have to be enabled. Timer 11 at this location of 18th position. So we will easily do this ADC one, same thing. So this logic and all same, guys. So one you are going to be shift up to 8 times to be set the ADC one. Okay, and timer, how many times I told you guys? In timer, you have to be shift up to 18 times. Okay, so since to this, we done the procedure of enabling the peripheral. Okay, enabling the peripheral. For if you're just using ADC one, same procedure going to be provided. If you're just simply using this, so this is how it is actually going to be work. Okay, so we are just accomplished up to the enabling the GPI opens and enabling the peripherals accounts. Okay, now after this procedure, you have to be set the mode. So why this mode is going to be set right now? We just enable the GPIO. Which GPIO pin it is? A, B. Okay, inside that, which pin you are going to be use? Yes, exactly, still. Okay, so Prashant has been answered. So super Prashant. So sorry for not acknowledging you. Okay, so here the GPIO-A, this one is port pin number 1, another one is pin number 9. This pin is 11. Okay, so based on that, we have to use it for the multiple applications. Okay, ADC is different application and timer is different applications. UART is different application. So both all the things are going to be do the different application. We have to be set to the which mode it is actually going to be performed. So for to be analyze that, you have to be go to the mode or register for to be set to the mode. So inside this GPIO register, you can able to see the mode. Okay, so you can also get that mode or register on here. You can able to see that mode A, GPIO A and GPIO B. So ADC and user we can use this. Timer we are going to use this. So in this ADC and UART, you can able to see this mode R as presented here, but the bit that means pin is only going to be changed. but the same motor is going to be performing. Here you can use the motor of ADC, the motor of user. But since it is having a same address only, if you just check it here, same address only. I'm just using. Okay. So why we need to use this channel? Why we need to use this motor? So the motor is normally, if you study about the general GPIO, we know that it is for the general purpose input and output device. You can able to get the data, give the data. Other than that, you can do the alternative function, analog mode, in output mode, input mode, and all. Right? We can able to do the different functionality because the peripherals are all doing the different function. If you're just taking an ADC, it is going to be performing in the analog mode. If you're taking one LED, if you're taking one sensor, like if you're other, we are going to be choosing any sensor, it is going to be collecting the data. It is going to be act as an input. Okay. So you can ask me the questions why we are not choosing input. Because it is an analog device. So analog, we are having a separate mode. LM35, we have to be using this analog. Okay. And UART. UART is going to be act as an alternative function. Why? Because inside this UART, you can do the multiple functions. Like you can able to transmit the data, you can receiving the data. So whenever it is actually doing the multiple functionality, it is the alternative function mode. Okay. And not only this, if you're just taking a timer also going to do the multiple function, input capture, output capture, kind of multiple function going to be performed. So for that, I'm going to be configured timer and UART are alternative function and ADC in the analog function. So what you got is you are going to be implemented in your code. Okay. So first of all, you have to be set the motor register. For GPIO, I just enabled the motor register address. Okay. And GPIO as having a different motor. So don't confuse it, guys, because GPIOs and all, it is having a different motor address. You have to use the motor. GPIO motor address is this. I just taken the address from here. So got clear. So thank you, Mukesh Kambal. So super. So no worries. You can join it from here after. Okay. So now I've been written the address, guys. Now I'm going to be set the bit. Okay. First of all, we will complete the ADC. Yes, Dhanuraja. So definitely I'm going to be telling. Don't worry. Okay. So once you will complete this flow, you can able to easily understand the concept. So first of all, I'm just using ADC motor. Likewise. UART motor. Likewise. Timer motor. Okay. We will complete the motor register for 3 peripherals. First of all, UART motor for ADC mode. So I'm just to go to this motor register. Here you have to be choose ADC pin number. You have been chosen of pin number 1. UART you have been chosen the port pin of 9. Timer you have been chosen the pin port B of 11. Right? I think it's 11. Yes, we have been chosen the port B of 11. Okay. So this one, first of all, you have been enabled the port A of 1, 9, and so you don't confuse whether in this reference manual it's just having a for GPIO is having different mode or no. It's for common. Okay. But while you're going to be using on here, the address and all going to be varies. Okay. So they have been given the common mode for all the GPIO bits. Okay, I'll be taking for your specific one, configure the address and bits going to be same only. Okay, so first of all, you have to be configure for ADC one. So ADC one, what you're going to be do here? ADC is going to be act as an analog. I need to be set in the bit called as an A11. Analog mode is going to be configured as an 1 1. Okay, so in this port A of bit pin 1, I'm going to be configure 1. Okay. And UART has been connected with a pin of port A of 9th. So you have to be, don't confuse, see the position, these and all the positions. You have to be set the pin number. This is the pin number. So this is the 9th pin. Okay, 9th pin, I'm going to be set the alternative mode. Alternative pin number is 10. Okay, I'm going to be set 10 on here. Okay, and then timer 11. So 11th pin, I'm going to be see it on here. I need to be set what? It is also the alternative function. I need to set 1, 0. Okay, that's it. So now I'm going to be implemented in this code. Okay, so since it is having multiple what can I say? Double pins. It is since it is having a two bits. I'm going to be set the 2 bits of value. Okay, so we know that if you are going to be set the bit, you have to be use the OR operator and left shift. But it is having a 2 bit. You have to be checked. What is the binary? What is the value of 1 1? So binary we have to call it as a 1 1. In digital format, so we have to be called it as well, you're going to be converted to the normal number. So we have to be called 1 1 is the value of 3. So 3, I'm going to be set. Okay, you can able to see this. 3, I'm going to be left shift after 2 times. So initially this is in the location of this position. How many times you are going to be shift? It just consider the 0th position 1, 2. So when you are going to shift up to 2 times, the 2 bits is going to be located at this position. So when you're going to be shift this bit, automatically this bit is also going to be shifted. Okay, so you have been shifted the bit. Okay, if I want to be set this bit, what are you going to be do? It is 1 0. What is the value of 1 0? It is 2. So 2, I'm going to be shift. How many times I'm going to left shift? I'm going to do up to 18 times. Okay, so while you're using a 2 bits, okay, so automatically this bit is going to be represent. Don't need to be worried. So same for you have to configure for timer 11. 1 0, it is 2. You have to be set up to 22 times. Shift up to 22 times. We can see it on here. I've been set the port A of 1. I've been shifted. I've been shifted for 80. 2, I've been shifted up to 18 times. Timer, I've been shifted for here, don't confuse it. Why we have been using instead of 18, we are using some other pins. So it just for we just simply configure. Sorry guys, here we are using a moda register, and we are using a 18th pin. Actually, give me a minute. Okay. So we are using a timer 11 only. Okay. And here I'm just using a 19 cross 2. Okay, we are going to be using a 18th pin. Okay, so that's what we are just using the motor of this one. So you might be asking this question, so why we have to be use this UART one? Okay, you might be asking this question like why we have to be using this UART one of resetting this bit. So the resetting bits condition is here it is having a 2 bits. Some bit might be already configured. Okay, some bit might be already configured. I have to reduce this one. We just using the clearing the bit. Okay, we just using the and we have to using the not operation. So for to be clear the bit, you have to use this two operators. Okay, to clear out the bits. Okay, so I'm just simply clearing the bit, and then I'm going to be setting the mode register. Okay, so after I just complete these things and all, so after I just completed the setting the bits and all, I'm go to the position. Okay, so sorry guys, here also we are going to using the port P of 9th pin. So I was confused. It is a timer 11. Okay, I hope I already informed you. Can able to see this when timer 11. Yeah, timer 11, we are using a port B of 9 only. Okay, so that is the thing. We have been using a 90. Okay, here you can use 18 directly, or else you can use 19 cross 2 these and all some math function. It is both are common only. Don't create thing. Okay, so here we are using a port B of 9, guys, not port B of 11. Okay, so we are using a port B of 9th pin. I'm just setting the bit. Okay, first of all, I'm just initially reset the bit. I'm just I'm going to be, after I'm just set the bit. That is clear. Okay. And hereafter, after we just configured all those pins up to the moda we have been completed, now we have to be work on with each and every peripherals. Like which pin, what is the functionality of EDC? What is the functionality of all those stuff? We have to be configure that. Okay. So how we can able to do this? How we can able to configure that? We have to be study about each and every peripherals. First of all, you have to be study about the ADC. Okay, in this ADC, you can able to clearly study about the concept, ADC concept on here. Okay, so why we cannot using this ADC? Because this STM32 microcontroller, it is having only the ADC1. The ADC2 and ADC3 is not available. It is having only the ADC. Okay, that's what we are using this one. Okay. Yes, guys. Okay. So before we have to deeply study about this concept, so that I'm going to be tell about the recorded session and all, guys, and we will move to this live again. Okay. So guys, I'm just telling you. So we will verify. Okay. So why no? So moda register, in this moda register, the question you are asking like it is going to be move up to 19 times. No. So it has been started from 0 itself. Okay. You have to be consider 1, 2, 3, 4, 5, 6, 7. So the bit position has been located at this one. So you have to be shift up to 18. The position has been, they have been mentioned. Okay. So you don't need to be counting. No need to be count. They have been given the position. You just easily put 80. That is the position. Okay. And here we will first of all complete the ADC bit. Okay. So if you want to do this ADC, guys, there is ADC 2 and 3 is 2 and 3 is not available. Only ADC 1 is there. So you have to be clearly study about the ADC. Okay. What is ADC? Okay. And what is the rest bit of ADC which had been provided? So because of the bit it is actually provided. Okay, you have to be get the resolution value. Okay, when you are most probably uh, you have to be get the high resolution bit. The Arduino it is having a 10-bit resolution. Okay, so if you are just getting a 12-bit resolution, you will get a more precise data. Okay, because the ADC means the analog data gets sampled and it is converted into the digital format of data. Okay, while you're going to using the 12-bit of ADC, what is the power of 2 to the power of 12, which is 4096. You can read the value up to, you can sample the value, you can get the value up to 0 to 4090. If you're using a 10-bit ADC, it is slightly less, 1023 only, 1024. Okay, so based on that, you will get the more data. When you get more data, you will get the accurate value, precise value. So ADC, it is having a 12-bit ADC. You can have a 16-bit ADC as well. And you have to be check the 19 multiplexed channel and 16 external source you can able to connect it. And internal 16 two internal sources. So what is the ADC conversions? And it is having a scan or discontinuous mode. The result of the ADC is going to be stored on left or right aligned 16-bit data register. So it is having a 16-bit of data register. The data register means it is going to be holding the final data, but it is a 16-bit. Okay, so in this ADC main feature, you will have the 12-bit, 10-bit, 8-bit, 16-bit configurable resolutions are possible. So you have to be study about all those main features. Okay, what is supply voltage? So we'll directly work on the value that is a program. So that's what I just read out the registers only. Okay, the core features and all you have to be study later. Here, first of all, I need to be enable the ADC module. So because ADC which is present inside the microcontroller. Okay, so I need to be on the ADC first. That is the ADC on off. If you want to be on the ADC, ADC is on, powered on, by setting the bit of add-on bit. So add-on is one of the bit which is present inside the ADC module. If you're enabling that bit, the complete module, the ADC module is going to be on. Where it is actually located, which is located with the R2, CR2 register. So inside the CR2 register, a add-on bit is there. While I'm going to be enable the bit, complete ADC module is going to be enabled inside the microcontroller. So this is what you're going to be set. So when add-on bit is going to be set for the first time, your complete ADC module is going to be powered on. So now you can able to get the analog data. So at the time, so you're going to be on the data. What will be happen? Conversion start. Okay, when you're going to be on the things, the conversion is going to be start. It's having two types of conversion, either SW start, JSW start. Bit is going to be. So here they have been given two types of conversion. You have to be concerned about what is meant by two types of conversion. Okay, either this or that. Okay, you can stop conversion, the put ADC powered down by clear the add-on bit. You are going to be stop the complete thing. Okay, so the two things have been fired up. First of all, I need to be enable the add-on bit. So here I've been enabled the add-on bit, which is in the CR2 register. You just simply go to that, just duplicate this reference manual and just go to this. Yes, guys, I'm going to be provide the example. So before going to be leave the session, guys, I'm just provide the attendance link. Uh, Okay, so here guys, what the thing you have to be understand is you have to be add on the bit. So you have to be set the bit. That is ADC going to be turned on. After that, you have to be clock going to be enabled. Okay, so we have been already done the clock enabling. So it is in the connected with this RCC of AVB 2 bus. With the help of this ADC, what has also been enabled with this digital format. Then you have to be enabled the channel selection. Which channel you are going to be actually going to be enabled, whether it is regular group or injected. What is my regular or injected group? So the regular channel means the order conversion sequence must be, you have to be enabled on here. Up to 16 conversions is there. So the regular channel means it's a conversion sequence with the selected channel. That means it's having the multiple channel over there. Okay. In that, you have to be specifically select the channel with the help of this register. So while I'm going to be select that specific channel, through that you can able to collect the data. Got it clear, guys? Up to this, we got clear. Just post clear message on the chat. Okay. I hope got clear. Varnat Gupta, Mukesh Kampal, and everyone posted got clear. Thank you, guys. Here, we are having the multiple channels over there. You are having the multiple channels, which is present inside the ADC module. Okay, inside this ADC module, you are having the conversion sequence, which is the ADC 1, 2, 3 kind of multiple channels are there. Okay, inside this, you have to be select the with the help of the sequence register. You can able to select the which channel you're actually going to be use. We know this one. Which channel we are going to be use? It is ADC1. Okay, so we are going to be use the sequence channel 1. We can use it. Okay. So I can use the channel 1, guys. I'm going to do this. Give me a minute. I'm going to be select the channel with the help of this SQR register. So here I'm having the multiple SQR register. So in this multiple SQR register, the channel 1 is presented at this SQR3. Okay, I need to be enable this channel. Here they didn't give any data to be set to bit or kind of thing. Here you can simply use SQR1, you have to be enabled. Because it is each R complete channel. SQR1 means you want to be enable the channel 1. SQ2 means you have to be enable the channel 2. Through that channel, you can able to collecting all the data. Okay, I need to be enable the channel 1 with help of SQ1. So I just enable the SQ3 is equals to 1. I need to enable the channel. So up to now, we just enable the ADC module and channel. It's completely for ADC. Okay, likewise, you have to be implemented for the UART and all. Okay, we will later on we will discuss that. First of all, we will complete the ADC configuration. Okay, so in this main function, we already studied that always your code starts from entry point is main code, main function. Right, always your code starts from main function. So in this ADC1, so on while one means it is continuously, the repeatedly it is going to be up. You will have this question like, what is the difference between while of one and what is the difference between while of? You can tell me the difference on the chat box, guys. I'm going to be see how many people are going to tell this answer for this question. What is the difference between while of one this, while of this? You can post the answer on the chat. Okay, I'm going to be telling the answer. So this while of one. Yes, Naveen Kumar, exactly. The first while of one is for the infinite. Okay. The second while of one is it's do nothing. This is for yeah, it's for execute for it. And this is for do nothing. We have to be actually this we have to be mentioned in sorry for this one, guys. I mentioned it in wrong way. So while of we have to use the semicolon for to be do nothing, and we are having the different functions is there. Okay, so for do this one and we have to be do the multiple times. I need to be run this code. Okay, so multiple time we have to be run this code. Okay, for that I'm just using this. Okay, so yes. So the thing is, you have to be run this code for the multiple times. I'm just using the while one. Yeah, I'm just while one for this infinite loop. And in this code, you don't look out for the other peripherals. You just see for this ADC peripherals only. Okay. So in this ADC, I'm just using this. So after I've been studied this, we have been studied this one. So you have to be see the single conversion mode or injected continuous conversion mode. You have to be analyzed that. So what is meant by single conversion? What is meant by continuous conversion? So single conversion mode, ADC does only one conversion. The mode is started with the on bit at 0. Okay. This is what it is going to do. So setting the SW bit of CR to 0 for the regular conversion. It is for injector conversion. Okay. You have to be analyzed that what is meant by continuous and what is meant by single conversion. So most probably you are going to be using the continuous conversion. So ADC start for new conversion as soon as possible, as finishes for. So if you are going to convert the one analog to digital conversion, it move to the next. It will be get new analog data, need to convert. New analog data convert. New analog data convert. So what we need, if you want only one data will be converted and stop the complete program, no, I don't want that. I need to be get the data convert, get the data based on. So I'm just simply using that SW start bit of CR2 register for the regular channel. Here also you can easily get that it is continuously going to be do the function. If it is doing only one time, I can use it in this normal configuration. Here it is going to continuously going to do this. That's what I'm just using in this while one. because it is continuously going to be happens. So here I'm going to be enable the SW start bit, which is presented at the CR2 register. So where CR2 register is there? So in the CR2 register, here you can able to see the CR2 register. CR2 register which is present at this SW start bit. So I'm just go to this SW start bit. I'm just go to this register of CR2 register. In the CR2 register, I can able to see that SW start. It is continuous in time. I need to enable this bit. What I'm going to do? I need to set the bit of 30th bit. So 30th bit I'm going to be set. What bit I'm going to be set? 1. So left shift up to 1. So this I'm going to be did on this loop because it is continuously going to be do this functionality. Okay, SW start bit. It is continuously going to do this operation. So before what you're going to do, you need to write the address. What is the CR2 address? So you just simply take on this and write the address. That's it. And after you have been completed this one, this is actually going to be start the conversion. Okay, that we have been studied on here. So once you have been started the conversion, the regular group of channel going to be converted. The last converted data are going to be stored into the TR register. Okay, that is last converted data going to be stored means if you are having one digital analog data, it is going to be converted to digital format that is going to be stored in the data register. For each and everything which is having a different register on for to be start the conversion, for to be store the conversion data. Okay, so why it is inside this loop means you just think it, guys. Here I'm going to be using this analog to digital converted data. I'm going to be received on here. Analog data is fast. I'm going to read it continuously. It is continuously providing the analog data. It is continuously going to be converted to digital. That continuous data is going to be sent to the another device, microcontroller. It is continuous process. Okay. So in this time, what I can able to do? What we can able to do? So what you can able to do? It is continuously going to be happens. Okay, it is continuously going to be happens. That's what we have to be written inside this. Okay. After this, you have to be store the data on the TR register. And after you have to be set the EOC end of conversion flag. The set you have to be set this EOC bit. It is a flag. So whenever you just saying it is flag, flag means why you have to be using this flag register. It is EOC which is presented at the same CR2 register. So which is presented at the same CR2 register. This flag is there. You have to be set the EOC. But EOC is for the setting as a flag condition. That means in normally I'm just doing a conversion. Okay, I'm just doing the analog to digital conversion. This is continuously going to be happen. Final data are going to be stored in the data register. That is fine. But when it is like what can I say? Here we have been using this data end of conversion. That is end of conversion flag is set. It means once it has been ended, okay, you need to be sent the data. You need to be sent the data kind of thing we can able to do. So that's what we are going to be using the EOC bit, but we have been using the checking condition. Again, I'm telling whenever it is a checking condition, you have to use the AND operator. When you're going to be clear the bit, you have to be use and not operator. Set bit, you have to be use OR operator. So this thing you have to be memorized on your mind. Just keep it on. Guys, can you able to hear my voice? Okay. I hope my voice is audible now. Okay. Yes, guys. Yes. Yes. So the thing which you are going to do is, yes, guys, so we will do this, like what can I say? We will complete up to ADC and we will continue the other steps on tomorrow. Okay, we will complete up to ADC because I'm taking more than 1.5 hours. So, yeah, guys, I'm going to be tell it again. Don't no worries. We will continue the UART and timer on tomorrow. So, we will stop up to the ADC. Okay, we will clearly got an idea. Here, guys, I'm just what I've been left is why I'm going to be using a while one. Why I need to write inside this while one, this SW status, because it is continuously going to be do the operation. Okay, because it is going to be continuously going to do the operation of analog to digital. Okay, so analog to digital conversion is continuously going to be happens. Okay, that's what I've just written inside this while one. Here I've just simply enabled the CR2 register of that control register has been enabled. That means that CR2 register have been enabled. The SW start has been enabled. Okay, it has been enabled. Okay, so in this case, after I've been enabled this one, I'm going to be check the EOC bit. Okay, I'm going to be enable the EOC. So EOC means once the conversion has been completed, how it is actually going to be work is, you are just collecting one data. For example, analog data, you just simply getting. That analog data is going to be converted in the form of digital. The final digital data is going to be converted. Once it has been done, you have to be set the EOC. That is the end of conversion. The conversion has been in. And after that, you have to be sent it, you just store on the data register. Okay, you have been centered on the data register. This is the flow actually. Okay, so the thing is, you have to be checking the condition. Here I'm just using a status register of ADC. Previously, I've been enabled of status register. Here you can able to see the SR register. This is the SR register actually. Okay, so this is the SR register. Inside this SR register, you can able to see the EOC. So you are going to be enabled the EOC. So inside this EOC bit, you have to be enabled. While you're going to be enabled, you can't directly do this enabling or disabling, guys, because it is just regular channel of conversion. Conversion not completed. The conversion has been completed. You have to be set the one. So the conversion might be oscillated. If the conversion was not completed, it keep on. It is having zero. Okay, you can't set the bit or reset the bit like that. For that, what I'm going to be do this, I'm going to be check condition. I'm going to do the check. Whenever it is a check operation, you have to be use the AND operator. Whenever you want to reset the bit, you have to use the NOT and AND operator. Whenever you want to be reset the bit, you have to use the OR operator. I'm going to do the checking the condition for that. I'm just taking the complete old register because I'm just taking complete register and I'm going to be shifting the bit for one time because EOC is located at this first position. Okay, what I'm going to do is, first of all, I'm just taking this register. If I'm declare this register, it is considering the whole register. Okay, SR register, consider the whole register. I'm going to be OR operator bit. I'm going to be trying to shift up to one time. Okay, because one I'm going to be set at the left. I'm going to be make left shift up to one time. Keep on checking the condition. Okay, so they keep on checking the condition. When I keep on checking the condition, first of all, initially it is in this 0000. When I'm going to set this 1 bit, so it is also 0. Okay, so when this position is get 1, when this flag is get 1, and I'm going to be shift the bit 1, when it is actually making this condition as true, that then only it is end of the conversion. Because this SR register is not by ourselves. When the conversion has been completed, it is automatically going to be set it as 1. So when it is 1, I'm just doing manually setting the bit as 1. This is manual shifting. This is pi. When it is actually completed the work, the register itself setting it as 1. The whole process has been completed. We are just setting 1. Okay, it is automatically the end of conversion. Once the conversion has been entered, you have to get the data from the TR register.